So we're going to begin our study of chemical kinetics, and first off we want to define what exactly is chemical kinetics. Kinetics is the area of chemistry that concerns reaction rates and reaction mechanisms. The rate of the reaction is how fast or how slow the reaction takes place, and the mechanism is the step-by-step process by which the reaction occurs. Reaction rate is defined as the change in concentration of reactant or product per unit of time. Another way of saying that is it's the speed at which the reactants change to products over time. We can write that as in an equation where we see rate is equal to the concentration. Remember, the square brackets around a formula means concentration. So concentration of reactant A at time equal to T2, final time, minus concentration of reactant A at time equal to T1, divided by T2 minus T1. Again, that's final minus initial time. We can condense that where we have rate is equal to the change in the concentration of reactant A over change in time. If we consider this chemical equation, notice we have one reactant. There's two molecules of it, yielding 2 molecules of NO and 1 molecule of oxygen. The reactant concentrations are always decreasing over time as reaction proceeds, and the product concentrations are increasing over time. So we will see a negative sign in front of the NO2, and we will see a positive sign in front of the products as they form because they're increasing over time. When you write the reaction, the rate expression, that's what this is called, you would write rate is equal to negative because they're decreasing over time. The coefficient, you take the reciprocal of the coefficient from the balanced equation, so 1/2 change in concentration of NO2 over change in time. If you wanted to write it with respect to the two products, you would say a positive sign because they're increasing over time, 1/2 because of the two coefficient, take the reciprocal, change in the concentration of NO over change in time, equals positive change in concentration of oxygen over change in time. Again, this is called the rate expression, and it comes from the definition of rate. A couple of things you need to understand about this. You could represent the reaction rate graphically, and we can measure the appearance of the reactants, the disappearance of the reactants. Here we see they're disappearing over time. Or you can measure the appearance of the products. Here you see the red and the blue lines. These are proportional stoichiometrically. If you look at the balanced equation, for every 2 molecules of NO formed, 1 molecule of oxygen is formed. So you can tell us this is double this. Likewise, for every 2 molecules of NO2 that disappear, 2 molecules of NO appear. The reaction rates are equal to the slope tangent to that point. You can see here, if you look at the change in concentration of NO2 over change in time. And the reaction rates change as the reaction proceeds. If the rate is dependent upon the concentration, so the rate of a reaction decreases with time. So reaction rate is not constant. So you'll see in our rate laws that one of the methods we use is called method of initial rates, where we can measure the initial rates of the reaction. Our next video will focus on the rate laws.